everyone, welcome to my YouTube channel. So this is our last lecture of a Newton's law of motion series. In this lecture we are going to solve all the PYQs from 2022 to 2025. Before that I already made 6 videos and I uploaded all the 6 videos. In all the 6 videos we have already solved all the PYQs from 1988 to 2021, and in this last video we are going to solve all the PYQs of a NEET Physics examination of a Newton's law of motion chapter from 2022 to 2025. I hope all these videos are quite helpful for you and you are enjoying my lecture. If you have any doubts coming, you are going to ask, and if you have any personal problem you are feeling, you can also message me personally, and you can also join my Telegram channel. So I hope we start about this lecture, and in this lecture we are going to solve all the PYQs. So this question from NEET 2022. In this, what they are asking in this diagram, what they are saying that the normal reaction of a force between 2 kg and 1 kg, 2 kg and 1 kg. So here you see that here 60 Newton force is acting here and 12 Newton acting here. So net force is more, so net acceleration in this direction, and both are touch with each other, so they have a common acceleration. So which I say F net divided by M total. So here acceleration is equal to F total. So here you see 60 Newton is upward direction, 80 Newton downward direction, that's one negative. And here you see that each and every block, if I put on this badge, so they have acceleration in downward direction, which I say mg sine theta. So can I write here, this is also mg sine theta, this is also mg sine theta, this is also mg sine theta. So this is also negative come, and here g sine theta I take common, and their mass is different. So 3 plus 2 plus 1, and that is g sine 30 degree divided by the total mass 2 plus 1 plus 3, that is 6. So here common acceleration is comes out to be 60 minus 18 minus this is 6. G value is 10, 30 is 1 by 2 divided by 6. So this is 3. So that is comes out to be 60 minus 18, that is 42 minus 30 divided by 6. So that is comes out to be, here you see that 12 minus 6, that is comes out to be 2 meter per second square. 2 meter per second square. Now we got the acceleration value. Now we can find in this the normal reaction between 2 kg and 1 kg. So here you see that we make the free body diagram of 1 kg. Here you see that 1 kg. Here this is our 1 kg, and here you see here 18 Newton force acting here, right? And here this has a mg sine theta acting, and normal reaction from 2 kg acting upwards, right? So we can write equation of motion for this, and the common acceleration is upward direction, that is 2 meter per second square. Now we can write equation of motion F net is equal to mass into acceleration. So that is normal reaction minus mg sine, this is angle they have given 30 degree, mg sine 30 degree minus 18, that is equal to 1 into acceleration is 2. So normal reaction is comes out to be, here you see m, g is also 10, sine 30 is 1 by 2 minus 18 that is equal to 2. So normal reaction is comes out to be, that is 5 minus 18 that is comes out to be 2. So normal reaction is equal to 25 Newton. So any option is there? Yeah. So option B is correct. Option B is correct. Now I proceed for the next question. This is also NEET 2023 question. And in this what they are saying that calculate the maximum acceleration of a moving car so that the block lying on the floor of the car remains stationary. The coefficient of static friction between the body and the floor is this. So in this situation, I just make the free body diagram so that you can understand this. It is like this situation. This is a car. And in this car, there is a block is going to be put, right? And this block and this car is going to be accelerated, and they're asking what is their maximum acceleration so that this block remains stationary. So if this car is going to be accelerated, so pseudo force acting on this block is opposite direction, and so opposite to it here, static friction is going to be acting. If this block is this block remains stationary only when this pseudo force is less than or equal to this static friction, maximum static friction, that is limiting friction. We know that is m a max, maximum acceleration, that is so that this block remains stationary, mu s into normal, and a max can I write here mu s into normal is mg. So can I cancel m cancel? So this comes out to be maximum acceleration so that this block remains stationary, that is mu s into g. So mu s they have given 0.15 and g is 10. 0.15 into 10. So this comes out to be 1.5 meter per second square. 1.5 meter per second square. So option B is correct. Now I proceed for the next question. This is also very good question. Football player is moving southwards. So just first I make the diagram so that you can easily understand this. This is our direction location. This is east, this is west, this is north, this is south, right? Over here you see a football player is moving southwards. So they are southwards and suddenly turns towards eastwards. So first they are moving southwards and then suddenly turns towards eastwards. So what they're asking, the force act on the player while turning. Force acting on the player. So can I say force acting on the player, that is change in momentum divided by time interval. If I find change in momentum, that we can find the force acting on the player. So I say initial momentum is m n v minus j cap. Final momentum become m v plus I cap. So change in momentum is, that is comes out to be p final minus p initial. P final here you see m v I cap minus p initial m v j cap. So change in momentum we can say that m v I cap plus j cap. So this comes out to be Sorry, I cap plus j cap. So can I say that? Just sorry. So force is basically change in momentum divided by time interval. So this give the direction I cap plus j cap. I cap plus j cap is in this direction. So this is northeast direction. Along northeast direction. So along northeast direction is which? So option B is correct. Along northeast direction. So option B is correct. Option B is correct. Now I proceed for the next question. A 1 kg ball strikes a ball with the velocity 1 meter per second at an angle of 60 degree with the ball. So it is like this situation. I make the diagram so that you can easily understand. Just a minute. This is a ball. And they strike and then return. Right. So here they say that a 1 kg ball, it is like this. This is a 1 kg ball. It strikes a ball with the velocity 1 meter per second at an angle of 60 degree with the ball. 60 degree with the ball and reflects at the same angle. Same angle. If it is in contact with the ball in for the contact with the ball, that is time is 0.1 second. So what they're asking, the force exerted on the ball. So force exerted on the ball we can calculate. So this is, we know that change in momentum along the normal to the plane. If I resolve this, so this is comes out to be here, you see this is mv cos 60 degree. Here they comes out to be mv mv sine 60 degree. And after returning this, they go like this. So after returning this, change in momentum mv sine 60 degree. And here this is also mv cos 60 degree. So change in momentum along the normal to the plane, only comes in phi direction, only x direction, sorry. So P final minus P initial. So can I say P final is, this is our P initial, this is our P final. So P final is minus mv sine 60 degree minus mv sine 60 degree. So that is comes out to be minus 2mv sine 60 degree. So here mass is they have given 1 kg and their velocity is also 1 kg. So the change in momentum, that is minus 2m is 1, v is also 1, 60 degrees sine 60 root 3 by 2. So change in momentum is basically minus root 3. If I take the magnitude of it, this comes out to be root 3 kg meter per second. So force that is equal to change in momentum by time interval. So that is root 3 by time 0.1 second. This is comes out to be 10 root 3 Newton. 10 root 3 Newton. So 10 root 3 Newton. Okay. 10 root 3 Newton. So which option? Option C is correct. Option C is correct. A block of mass 2 kg is placed on the inclined rough plane AC as shown. in the figure. Coefficient of friction is mu. G is the 10 meter per second. They are asking net force on the block. So net force on the block, here you see that this is mg sin theta acting downwards. Mu s into normal mg cos theta acting upwards. So here you see that these forces are equal. So can we say that this block is at stationary, or net force is how much? Suppose if I say net force is basically mg sin theta minus mu s mg cos theta. So net force, if I take mg common, then sin theta minus mu s cos theta. So here you see m to g is 10, sin 31 by 2 minus mu s is 1 by root 3. Cos 30 degree root 3 by. So here you see f net is 20 into 1 by 2 minus 1 by 2. So here net force on this block is 0. Net force on this block is 0. So option B is correct. Option B is correct. Now if we proceed for the next question. What they are saying that a horizontal force 10 Newton is applied to a block A as shown in the figure. The mass of the block A and B are 2 kg and 3 kg respectively. The block slides over a frictionless surface. The force exerted by block A on block B. So for this type of problem, first find common acceleration. F net divided by m total. So net force is 10 divided by total mass 2 plus 3. So net is 5 divided 10 divided by 5. So this comes out to be 2 meter per second square. This is our common acceleration in which these two blocks attach and move together. So here I make the force exerted by block A on block B. So block B where force is going to be, this is 3 kg. So here you see that for block B the force going to be exerted by A. I say this is F. F is equal to F dash is equal to mass into acceleration. If I say F net is equal to mass into acceleration, F dash the force that block A going to give on B. F dash is equal to mass is 3, acceleration is 2. So F dash is comes out to be 6 Newton. So 6 Newton force given by block A on block B. So option C is correct. Now it proceed for the next question. A block of mass 5 kg is pulled by a cord up along a frictionless plane inclined at a 30 degree with the horizontal. Tensor in the cord is 30 Newton. The acceleration of this block is. So this is like a situation. So here you see that this block is on this inclined plane. Right? And in this, a block of mass 5 kg is pulled by a cord that has a tension of 30 Newton. They at an angle of 30 degree. So here you see that this is mg force acting. This is mg cos theta, and this is mg sin theta, and this is also normal reaction acting. So what they're asking, the acceleration of this block. So F net, can I write acceleration in upward direction? So F net is equal to mass into acceleration. So 30 minus mg sin 30 degree, that is equal to mass into acceleration. So 30 Mass is 5, G is 10, 30 degree 1 by 2, that is equal to 5 into A. So this comes out to be 30 minus this is 5. So 25 is equal to 5A. So 5 is equal to 5A. So A is equal to 1 meter per second square. 1 meter per second square. So option D is correct. Option D is correct. Option D is correct. Now this is our last question of a NEET 2025. There are two inclined surfaces of equal length. Two inclined surfaces. Okay, just 1 minute. So there is a two inclined plane. Sorry. This is two inclined plane. So I think first I make the diagram so that it is easier for you to understand. Two inclined plane of equal length. This is NEET 2025. Same angle. Their angle is also same. 45 degree, 45 degree, 45 degree. This is I say smooth, and this is our rough. Rough. One of them is rough and other is perfectly smooth. A given body takes 2 times as much as time to slide down on a rough surface than on a smooth surface. Means they are saying that time on rough surface is 2 times the time on a smooth surface. Smooth surface. Smooth surface. The coefficient of kinetic friction between the object and the rough is mu k. So here you see that there are two inclined surfaces of equal length and same angle of inclination. One of them is rough and other is perfectly. A given body takes 2 times as much as time to slide down on a rough surface. So it is like this. This is block on a smooth surface, and this is also on a smooth surface. So here you see that for smooth surface, acceleration is I say g sine theta. For rough surface, down they are coming downward, so their acceleration is g sine theta minus mu k cos theta, right? And one more thing, I say s is equal to ut plus half at square. They are coming downwards, so initial speed is 0. So I say that s is equal to half at square. So can I say that time is inversely proportional to and the length is same. So can I write this as t square is equal to s upon 2a. S upon 2a. So time is inversely proportional to acceleration, right? And here you see that what they are saying, time on a rough surface, just can I write this? Time on a rough surface is 2 times the time on a smooth surface. Time on a rough surface, that is, can I write 1 in root times 2 upon a rough smooth. So 1 upon rough, that is acceleration, can I write here g sine theta minus mu k cos theta, that is equal to 2 times, here I write g sine theta, right? So here g going to be cancelled. Then after that I send this root sine theta, that is equal to 2 times sine theta minus mu k cos theta, squaring both sides, squaring both sides, so I get sine theta, that is equal to 4 times sine theta minus mu k cos theta, right? Then after that what I do, I send 4 that side and sine theta that side, so this become 1 by 4 is equal to sine theta come that side, so this become 1 minus mu k cot theta, so I inverse of that is tan theta, and theta they have given you 45 degrees, so tan 45 degrees 1, so this equal to 1 by 4, that is equal to 1 minus mu k, so mu k comes out to be 1 minus 1 by 4, that is 3 by 4, so mu k is comes out to be 3 by 4, or mu k is 0.75, 0.75, so 0.75 is anything is there, yeah, so B is correct. So this is like a conceptual question, you know all the concept, then you are able to solve. So this is NEET 2025. I hope all the PYQs from the Newton's law of motion we have completed from 1988 to 2025. All the PYQs in 7 lectures I completed. Each and every question I solved in a detailed way as much as possible so that you can easily understand. And I hope all the lectures you are easily able to understand from the Newton's law of motion. I hope we are doing very well, and in the next lecture we are going to start our new chapter, that is work power energy chapter. And in the after some time so many students are messaging me, sir, starts our new chapter, that is thermodynamics, thermal properties of matter, thermodynamics and kinetic theory of gases. In the upcoming videos we are going to solve all the PYQs from thermodynamic portion. I hope these videos are quite helpful, and all the content which I am delivering you are able to understand, and these are quite helpful for me in your preparation. And I hope, just I wanted one request, please subscribe, like and subscribe my YouTube channel and share with the other people who are preparing for ITJ NEET examination, so that they got benefit of these content, and I try to give guidance if any problem they are facing in their exams. Keep tata, bye bye, we make in the next video very soon.